Hello and welcome all of you to this class course of mechanical design, a specially designed course for working professionals. And I am Chanukku Chatterjee, and this is the third video in this series. And today we shall be learning about the concept of scales and concept of projections. So we shall be learning today about the definition and what is scales, then reducing scales, then enlarging scales, full scale. Then we shall be learning about projection, what is projection, and associated with these projections, plane of projection, quadrants, the concept of quadrants we shall be learning today, and a very common comparison of first and third angle projections. So these are all those things that we shall be learning today. Let's come to the next slide. Scale. A scale is the ratio of drawn dimension to the actual dimension of the object. That means whenever I am drawing a machine part, maybe that machine part has such a bigger maybe has bigger dimensions, which is not feasible to put into the standard drawing sheets. Then in that cases, what we do, we may reduce the actual dimensions, or we may increase the dimensions from its true form. That means maybe the dimensions are of the actual object is much higher, which is not feasible to put into the drawing sheet. Then we can reduce the dimension, or let's say our dimension of our real object is too small to draw in the actual drawing sheet. Then we have to enlarge it. So to what extent we are reducing or enlarging the true dimensions of the object, that is called a scale. So reducing scale, when a drawing is made smaller to the actual size of an object, then the drawing is in reducing scale. That means if the real object is of much bigger size and we are putting it into the smaller size, that is then the entire scale will be called the reducing scales. General reducing scales are 1:2, 1:2.5, 1:5, 1:7.5, 1:10, 1:20, 1:50, 100, 200, 500, 1000, etc. I would suggest that you please keep a note of these scales, because this is going to be helpful in your during your drawing production. These are the very standard scales that we follow in industrial drawing production, and I think you should keep a note of these particular scales. You have to follow accordingly. A scale of 1:10 means the drawing has been made 10 times smaller comparing to the real shape of the object. That means if let's say the diameter of any cylinder or any round portion is, let's say, 1 meter, then now I cannot put the 1 meter diameter in 1:1 format in the drawing set, because that is too big to put in a drawing. So in that case, what we do, let's say we are drawing it in 1:100. In a 100 diameter circle, we are representing the actual 1 meter diameter. Then it will be said that the drawing has been made in a 1:10 scale. Similarly, enlarging scale. In enlarging scale, drawing is drawn much larger comparing to the actual shape of the object. This is just opposite of the reducing scale. In this format, we are enlarging the actual size of the object in our standard drawing production. Usual enlarged scales are 50:1, 20:1, 10:1, 5:1, 2:1. I shall suggest you also keep a note of these standard scales, because sometimes what happens, you have to show a sectional portion of any assembly or any object, or any part of any object. You have to show it in a much enlarged portion, or maybe in a wholesome drawing, you may have to show the entire each and every parts in a much enlarged view. Then you have to utilize these scales. These are 50:1, 20:1, 10, 5, 2:1, etc. I would suggest you keep a note of these scales. This is going to be much helpful in your standard drawing production process. A scale of 10:1 suggests the drawing is made 10 times larger comparing to the actual shape of an object. That means, let's take an example. You are drawing the parts of a wristwatch. Then in case of a wristwatch, the parts are too tiny to put in a drawing sheet. Even an A4 sheet is going to be much bigger to comparing the size of the parts of a wristwatch. Then in that case, you have to put the parts in a much enlarged scale, and to what extent you are enlarging the true dimensions of the object, that is the scale of the enlarged, that shall be called as the enlarging scale. Full scale is 1:1. That means full scale means drawing is made with actual dimension as per the object. Let's say a washer. Whenever you are drawing a washer, then that can be drawn in a A4 sheet, and that washer will be in 1:1 scale, and that is called the full scale. Full scale is 1:1. Next we come to the projection. Projection is the superimposition of several faces or edges of any object on a plane when both are separate entity. That means, if you put an object and if you put an object in the universe, and let's say you are standing in the other side of the object, then whatever the image will be generated on the virtual plane of the other side of the object, that is called the projection. Lines which connect an object with plane of projection are called projectors. That means the lines, if these lines are imaginary lines, whatever these imaginary lines which connects each and every edges or points of the object with the image generated on the virtual planes or plane of projections, these lines are called the projectors. In engineering drawing, 4 different kind of projections are followed. That is orthographic projection, isometric projection, oblique projection, and perspective projection. So these are the four different kinds of projections that are being followed in the standard drawing production method, among which orthographic projection and isometric projections are being used rapidly, and oblique projections and perspective projections we also use, but not to that much of extent that orthographic and isometric projections. Only orthographic projection produces 2D views, while other projections create 3D views of an object. This is a very vital part. That means this is the only orthographic projection creates 2D views. Now remember that only by orthographic projection you can show each and every section, each and every side of an object at a single time, while isometric or oblique or perspective projection, it would be good to say that in case of 3D views, you cannot show the each and every portion, each and every edges of the object at the same time. Only orthographic projection can do that, and that's why orthographic projections is being used in the manufacturing scenario. This is the only projection that produces the 2D drawing, and that produces the manufacturing drawing also. So only orthographic projection produces 2D views, while other projections create 3D views of an object. All manufacturing drawing or production drawings are produced in the orthographic projections only. This is the vital part. That's why we have to learn orthographic projections so much. We have to learn this orthographic projection very carefully, and so that all manufacturing or production drawings are produced in the orthographic projections only. Now, plane of projection. Plane of projection are multiple different planes intersecting each other perpendicularly, upon which projectors produce image of the corresponding face or edge of an object. That means just what I have said to you, that is the plane of projections are imaginary planes, which there are 3 different kinds of plane. That is the vertical plane, horizontal plane, and the front plane. And let's say for now, let's consider the vertical and horizontal plane only. And plane of projections are the multiple different planes. These planes intersect to each other perpendicularly. And plane of projections are multiple different planes intersecting each other perpendicularly, upon which projectors produce image of the corresponding face or edge of an object. These planes are called reference planes, and the straight line along which two consecutive planes intersects each other is called the reference line. In the very next slide there is an image, and you shall have a clear conception about this plane of projections and the reference line. The projection on vertical plane is called front view or elevation, while projection on the horizontal planes are called the top view or plan. So just keep in mind that the image that is being generated in the vertical plane is called the elevation, while the image being generated in the horizontal plane is called the top view or the plan view. Now if you focus in this image, you shall see that this is the vertical plane. Remember that this plane and this plane are imaginary planes. Let's say you are keeping an object here in the first quadrant, then the whatever image will be generated, that will be generated in this plane only. So that so the image that is being generated in this plane will be called the elevation, while this whatever the image will be generated in this plane, that will be called the plan view or top view. Now keep in mind that this is the vertical plane, this is the horizontal plane, and these are perpendicularly intersecting each other at the point 0, 0, 0, 0, and this point is called origin. And whatever the line that is forming, that is xy line, this xy line, whatever line is being formed due to intersection of these two planes, these are called the reference lines. So this is what vertical plane, this is what horizontal plane. The image being generated on the horizontal plane is called the plan view. The image being generated in the vertical plane is called the elevation view, and this is the reference line. This point is 0, point, and this is the reference line xy. Now come to concept of quadrants. When reference planes extend beyond reference lines, they form 4 different quadrants. And reference of any object with reference to reference planes are denoted with specific quadrants. This is a very vital thing. You have to understand that whenever two planes are intersecting each other, they are forming 4 different segments. Now each segments are called each quadrant. This is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Now remember, first, second, third, fourth, it rotates in counterclockwise direction, and whenever we shall be making drawing in orthographic projections, if you have to learn a little bit more about the orthographic projections, because in this case I am being too precise or too short to describe each and everything. This is not going to be a full comprehensive method for learning a fresher. But if you are having a little bit of experience of the drawing, and if you are having a little bit hands-on experience in the engineering section, then you shall be able to learn it very quickly. If you have to learn in detail about the orthographic projection, you can go and to see the reference books that I have mentioned in the earlier video, and you can study it from there. But for now, whenever we shall be producing any orthographic projection, we can assume only 2 things. That is, either the object is being put in the first quadrant, or the object is being kept in the third quadrant. This is the only possible way. Whenever I am putting the object in the first quadrant, the image, whatever the projections or whatever the image or the drawing will be generated, that will be called the first angle view. And when I am putting the object in the third quadrant, then whatever the image or the drawing shall be produced will be called in the third angle view. So first angle and third angle projections, these are the 2 things you have to learn. And in the concept of quadrants, and these are the horizontal and vertical planes. Now it is a very It is a very important comparison. You have to learn it carefully, because if you don't understand this first angle projection and third angle projection, it shall become you shall be very prone to make mistakes during drawing production. And in case of complex drawings, first angle a clear differentiation of first angle and third angle projection is quite mandatory, because unless otherwise you know the difference, you would be making mistakes each and every time. So first angle projections and third angle projections, let me compare that. In first angle projections, the basic object is assumed to be kept in the first quadrant. That means whatever I have just said earlier, that here whatever, if I am putting the object in the first quadrant, then whatever image or drawing shall be generated, that will be in the first angle projection. And in third angle projection, the object is assumed to be kept at third quadrant. That means I am putting the object in the third quadrant, and whatever the image or being generated in the shall be called in has been drawn, the drawing has been made on the third angle projections. Object, in this case, object is assumed to be kept in between projection plane and the observer. That means the if let's say this is the plane of projection and this is the object and you are the observer, then whatever image of this particular object is being generated on this plane, that is you are seeing. That means from if you are putting an object in this side, if whenever I shall be discussing about this symbol, it will be much clearer for you to understand. Whenever whatever the image of this face of this image of this object is being whatever the image will be generated in this plane of projection, or this plane of this plane, that will be the image of this face of the object, not this face of the object, and you are standing here as an observer. So the object is assumed to be kept in between projection plane and observer. Here the projection plane is assumed to be kept in between object and observer. In that case, let's say this is the object, this is the plane of projection, and you are the observer standing here. That means whatever the image will be generated in the plane of projection, that will be of this face. That means whenever in the first angle projection creates drawing opposite side of the observation point, and third angle projection creates drawing of the same side of the observation point. That means whenever the object has been kept in the first quadrant, then we shall see this face of the object. That means you are looking from this side, and whatever image will be generated on the left hand side. If you are standing in the right hand side, this is the object, and the image will be generated on the left hand side. Now come to the symbol and let me discuss it on this regards. This is the object, that is a tapered bar. This is the smaller dia, this is the higher dia. The same as here. So whenever the object is being put, then the plane of projection is here, and the observer, as an observer, you are here. So what happens in the first angle projections, you are seeing the short dia first and then the larger. So what happens here, you are seeing the shorter dia at first, then you are proceeding towards the larger dia. So what will happen, you are seeing the shorter dia and then larger dia, and the image is being generated on the opposite side of the object, and the image is being generated here. This is the plane of projection. So that's why this is the symbol. And in case of third angle symbol, you are the observer and standing here. This is the tapered bar, and this is the image generated due to the plane of projection. So what you are seeing, this image is not being generated on the opposite side, it is being generated on the same side of the observer. Okay, so just understand that the image is being, in case of first angle projection, the image is being generated on the opposite side of the observer. You are the observer here, and the image is being generated on the opposite side. While in case of third angle projection, the image is being generated on the same side of the observer. That means you are standing here, and being an observer you are standing here, and the image is being generated towards your side. That is why this is the. Now these two symbols are quite important, because whenever you shall see in my second video, when I was showing standard sheet templates, I was having a very little discussions about these symbols. This this is a quite this is quite an important symbol, as whenever you are going to start a drawing or read a drawing, you have to just check whatever, check that this drawing is in which method this drawing has been followed. Now now in our Indian, now as per our BIS, Bureau of Indian Standards, it was earlier days we were following the first angle projections, but Bureau of Indian Standard has prescribed that we should follow third angle projections. And but in general cases, even in still today's practice, we also followed first and third angle projections simultaneously. There is no harm practicing first angle projections, because this is going to be kind of easy. I think in my conception, this first angle projections is kind of easy, while this is a little bit difficult for fresher practitioner to understand the third angle projections for complex cases. So both are being used in manufacturing scenario, in standard drawing production practice. But Bureau of Indian Standard has prescribed to follow the third angle projections. This is the thing that I need to mention. And for now, this is for now, up to today, that is, thank you. And for now, and also, if you have to learn a little bit more or extra about these things, you have to go and study from the reference book that I have just mentioned to you in my earlier video. And also, if you like this short effort of mine, kindly share and subscribe my channel Make Chanukko, and see you in the next video. Thank you. In the next video, I shall definitely discuss about various kinds of drawings with sample drawing sheets. I shall be discussing about various kinds of drawings. There are almost 20 to 21 different kinds of drawings are being used in the industries in our standard drawing production scenario, and you have to understand those things very carefully. For now, thank you very much.